Alright, so this is the third video and final video for our first lesson in Module 1, dealing with representing, naming, and evaluating functions. Example 3 here states that we're going to let capital X equal the set that contains the numbers 1, 2, 3, and 4, and capital Y is going to equal the set that contains the numbers 5, 6, 7, and 8, and 9. We also have two functions listed here. Okay, we can tell because we have an f and a g. So two different functions here. Well, actually we're going to see if they're functions in a second, so I shouldn't say they're functions. Maybe we can call them relations. And they are defined below. So here is f and here is g. So we'll maybe kind of like draw like a little divider line here to kind of keep these things separate. Okay, so the first question we're asked is f a function? We can see here that f takes x as its domain, right, the inputs, and it maps it to y, the outputs, or the range. And we can see the pairings right here in these ordered pairs. So the x element 1 is paired with 7, the 2 gets paired with the 5, the 3 is paired with the 6, and the 4 is paired with the 7. Now, is this pairing, are these pairings a function? Well, let's go back up to our definition up here. Remember that a relation is a function if each element of x, or of the domain, is matched to one and only one element of y. So going back down here, is every element of the domain, that is every x value paired with only one y value? The answer is yes. 1 is only paired with a 7, 2 is only paired with 5, 3 is only paired with 6, 4 is only paired with 7. So is f a function? Yes. Okay, so if yes, that's what we had. What is the domain and what is the range of this function? So domain, remember, describes the x value. So looking at our ordered pairs here, pause the video and go ahead and list the domain, or in other words, list all the x values, and then do the same thing for the range. Okay, so hopefully you paused the video and you had a chance to do that. If not, do that now, and I'm going to go over the answers here. So the domain is going to include the numbers 1, 2, 3, and 4 for these x values in their ordered pairs. And again, use the braces to group them. For the range, we're going to look at the y values. You'll notice that the 7 repeats. We don't need to write that more than once. So I can just write 5, 6, and 7 like that. Okay? Now, you might look at this and say, well, wait a minute then. This 7 happens twice. Does this thing still a function? And the answer is yes. Remember that it is every x value that gets paired with only one y value. The y values can get paired with more than one x values, but the x values can only get paired with one y value. All right, so let's take a look here at g. So again, what I would like you to do is answer this question. Is g a function? If yes, what is the domain and range? If no, explain why g is not a function. So go ahead and take a look up here at g and the function pairings that we have here, or the relation pairings I should say. 1 pairs with 5, 2 pairs with 6, 1 pairs with 8, 2 pairs with 9, 3 pairs with 7. Is g a function? And again, remember, we're looking to see, is every element in x matched to one and only one element from y? In other words, is one x paired with one y? So look at those x and y values there. Pause the video and answer the question in your head. Okay, hopefully you took some time to answer that question. It's very important that you do pause the video and think about these questions for yourself, because this is how you will learn and practice. You'll gain a lot more understanding by trying it on your own first before you listen to me for the answers. And I'll continue to remind you that in these first couple of videos. So is g a function? The answer is no. And why is that? Well, you can see right here that this 1 gets paired with a 5, but 1 also gets paired with 8. So we have an x value that's paired to two different y values, the 5 and this 8. Likewise, we also have a 2 that pairs with a 6 and a 9. And again, that's one x value paired with two different y values. So while these things are a relation, right, these things are related, it's not the special kind of relation that's known as a function, because the x values only should be paired with one y value. And we have these right here that are not good. So if no, explain why g is not a function. Well, we just did that, right? So you can use either one of those two examples, the 1 or the 2 that gets paired with both y values. You could also use both, but only one's really necessary. So you can say, you know, g, whoops, I'll use lowercase, g is not a function because the x value of 1 is paired with, oops, two different y values. Okay? Some other things that we can do with a function, we can answer questions like this. What is f of 2? Now again, we see here a lowercase f, so that means we're dealing with our function here to the left. Okay, and we want to know when x is 2, right, this is an x value here because it's an input, we're plugging 2 into the function. We want to know what is the matching y value here when we do f of 2. So we go back up to our ordered pairs here. Look at those ordered pairs. What is the matching y value when x is 2? Hopefully you said 5, right? There's the x value of 2 and it's paired with 5. So f of 2 is 5. If f of x is 7, then what might x be? Now here we change the question a little bit. Now we don't know what the x value is, but we know that when we plug that mystery x value in to the function, we get 7 as an output or as a y value. So in other words, we're asking what is x if y is 7? So we go back up here. Okay, again, looking still at f because we're just dealing with f. Which x value gives us a y value of 7? And the answer is 4, right? And so x must be 4. Or you could also write f of 4 equals 7. Either one of these is okay. All right. So that concludes the video, and we will talk to you next time.